All right, let's take a look, see if we can see what's going wrong here. So if we go down here, we can see the test cases. So we have the simple test case, 3589. We have the horses in any order. And so here's 10 horses in random order. And here's the mini horses, the one that we're failing. And there is a bunch. I don't know if they got all 10 million values that we're allowed to have in here or not. But it is a lot. And when we take a look at the failure, it's because we're getting a process timeout. So we're trying to do, how many comparisons are we doing? If there were one, two, three, hundreds, thousands, millions. If there were 10 million, then I would be doing 10 million times 10 million. How many is that? My math says that that would be like 100 trillion com comparisons we're doing, right? So we would be running this code 100 trillion times, and we're just timing out. It's too much. So now we run into the problem, okay, what are we going to do to reduce the number of tests that we do? Let's take a look at these hints. So here it says, don't get stuck. Use the following hints to help you find the solution. Simplest algorithm consists in comparing all the pairs of powers and then displaying the smallest difference. Um, but yeah, that's too much. So a better approach in order to achieve a score of 100%, it is necessary to find a way to avoid to do that many comparisons. Try to answer the following question. Which modifications of the input data would allow you to find the answer with a single loop? N-1 comparisons. So pause the video here. See if you can think of ways if we had, um, well, let's just take a look at this. Instead of doing, what are we doing? Comparing 8 to 19, that's 1. And then 5 to 8 and 19, that's 3. And then 32 to 5, 8, 19, that's 1, 2, 3. So we're at 8. And then 456 to 1, 2, 3, 4, 1, 2, 3. That's 10. And then 987 to 1, 2, 3, 4, 5. That's 15. So this is requiring 15 comparisons. And we should be able to prove this to ourselves, right? We should be able to do a system.error print line. That's fine. I'll just put in debug messages. And I'll play this test case. Oops. Need a semicolon. Let's try it again. Once more with feeling. All right, so I did 2 comparisons here. Oh, what exactly is that? I'm only outputting when the distance needs to be reset. Let's do this all the time. Yeah, so now we see it 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so let's reduce that from 15 to 1, 2, 3, 4, 5, 6. Let's get that down to 5 times. If we can get this test down to 5 times, we should have a good chance of getting this mini horses test case to pass. So what can we do? I have an idea. If you don't, pause the video, see if you can think of one. What I want to do is take these strengths and um, put them in order, sort them in order. So the smallest difference should be right next to each other, right? So then I should be able to compare, if I were to take a look at these test cases again, so the simple case, 5, 8, and 9, that is in order. So if I should be able to compare 5 to 8, that'll give me a 3. 8 to 9, that'll give me a 1. So I should be able to get those test cases. Now this one, this is not in order, but let's send this to the IDE. So here, if I were to reorder this, I should get a value 1 again, right? 6 and 7. When this gets sorted in the correct order, 6 and 7 are going to be right beside each other. And so I think if I can sort these and then do my comparison one time through the loop, that should fix my issue. Let's try that out in the next video.